this part is it's more workshop, okay? So for this seminar, we are going to talk about variable and constant sprints, okay? And a brief introduction about the use and the purpose of the sprint sway braces, okay? The idea of this, more than a presentation, is I will give you an introduction of what are the typical supports and the purpose of use sprints that are flexible supports, okay? And we are going to make some practical calculation of how we are going to select, okay, or calculate a variable spring and a constant spring. The idea is that I explain you what are the variable and constant springs, when I need to use one, when I need to use the other one, okay? And we are going to make some example of calculation, taking into consideration a load and a displacement, how we are going to calculate and select a spring, okay? So, it's not working with this. Okay, so as I mentioned, well, the ones that were with me in the previous conference, once the piping design has been done, okay, the stress analysis people get into, take that routine, and their job is to guarantee and to check the stress analysis of the pipe. So, as conclusion, to validate the routing of the pipe. For what is the purpose for the stress analysis to do that? Because they need, or we need to guarantee to ensure the structural integrity of the pipe. Such integrity is achieved through a correct selection of the support. When I mean correct selection of the support, I mean the location of the support and the type of the restriction of the support, okay? Even though if I have a perfect stress analysis, okay, who is in charge to design those restrictions indicated by the stress analysis is the support designer, okay? I can have a perfect stress analysis, but if the support designer doesn't take care to design correctly those supports, they can make that the system fail, okay? Because the stress analysis will design, for example, will indicate that in a specific point they require a guide. The support designer make a mistake and even instead of a guide put an anchor, an axial displacement, okay? It's just to make a mistake on the direction of the support, okay? That can generate that the system fail, okay? Because it's not what has been calculated, okay? So it's very important not only to perform correctly the stress analysis, it's also very important to perform correctly the support, okay? The support to place in the location that has been specified by the stress analysis, and also to design correctly the type of the support that I'm designing and constructing represent or restrict the degree of freedom that the stress analysis requires, okay? So the proper selection of the support is necessary to support the weight of the pipe, of course. The pipe, when I mean the support of the pipe, is the pipe, the fittings, the valves, the insulation, all the elements, okay? It's what we call the weight of the pipe. Okay, to control the movement, to control the loads that we are going to transmit to the structure and to the equipment, okay? To protect sensitive equipment, okay? Like compressor, heaters, exchangers, turbine, pumps, okay? To increase the system rigidity, to minimize the vibration of the system, okay? I can have the system that the point of view of stress levels and loads are correct, but I need to add some supports to make the system more rigid. Why? Because we need to minimize the problems with vibration, okay? We need to increase the frequency of the system, we need to move it higher, okay? This is important, consider an industrial complex that can be thousands of piping support, okay? So the design and the construction should be the most standardized possible, okay? In order to be quickly in the engineering phase, quickly in the construction phase, quickly in the installation, okay?